Hello, I'm Meghma Chakraborty. I'm doing the task 6 of the GRIP internship by the Sparks Foundation. It is the prediction using decision tree algorithm. The problem given is that our purpose is if we feed any data to this classifier, it would be able to predict the right class accordingly using the iris dataset. So firstly, I'm importing the required libraries, namely NumPy, Pandas, Seaborn, Matplotlib. Then I'm reading in the data, the iris dataset from the source. This is how it looks like. Then the information on the data is that there are 6 columns. We can see that there are 6 features in which 4 features are independent features and 1 feature, which is the species, is dependent on the target variable, and ID is just a serial number. Then there is some description of the data uh, as to count, mean, standard deviation, etc. Then we visualize our data using a strip plot like that, so that we can see that each class of species of flowers has equal number of data points. So our iris data is said to be a balanced data set. Now we also try to visualize our data using some distribution plots. So this is the distribution plot for sepal length, then for sepal width, for petal length, and for petal width. Next, I have done a heat map to analyze the relationship between the variables. So there the correlations are given so we can understand. Also, furthermore, there is a joint plot done to visualize and analyze relationship between two variables, the pairwise relationship, and describing individual distributions in the same plot. So firstly, I've considered the relationship between sepal length and sepal width. So it is something like this, the visualization. Next, the sepal length and the petal length. Like this. In here, the dark spots refer to more dense points there, and the lighter area means less dense. Then the sepal length versus the petal width. Here again, this is a hexagon plot. So the higher concentration, the darker hexagons refer to higher concentration, and lighter hexagons refer to lower concentration. Then the petal length and petal width is like that related, which is quite expected because it is the same petal length and width, so it may be having a linear relationship. Then the petal length and sepal width, and next is the petal width and the sepal width is related like that, and the individual bars are also given together. And then I have done a rock plot to draw small bars and to visualize more properly. So it is the sepal width versus sepal length. It shows that that is the rug within which it will all the data points will lie. Next, I've done a pair plot. So it comes out like this. So from here we can say that the cluster species of iris versicolor and virginica are closely related, whereas setosa is more distinct, because by looking at the result of the pair plot, we are sure that all the blue points are well separated with other two classes, but versicolor and virginica are partially overlapping with each other. So in pair plot, we saw that there are some feature combination which has less overlapping between versicolor and virginica, which means those features are very important for our classification task. Next, there is some engineering on the data. So I've taken the difference of the sepal length and sepal width and petal length and petal width and added it as a column in the data. Next, some furthermore shuffling of the data for some work afterwards. And this is the pair plot for the newly shuffled data. It comes out to be like this. So we see that with the help of a pair plot, we are getting some new information, but it is more likely similar with our main data features as we saw earlier. That is setosa, iris setosa is quite away apart from the other two, and the other two is overlapping. So every combination well separated from the iris setosa, but has some overlap between versicolor and virginica. Next, I'm building the classification model. And importing the libraries sklearn and the decision tree classifier for creating the decision tree, and separating the independent and dependent variables. Next, I'm training the data and plotting a decision tree using the decision tree classifier. So it comes out like this. We can see the Gini coefficient and the sample and the values. Next, I have fed in just sample data and tried to see whether it is giving the right class or not. So it is actually expected that it would give iris virginica. It's given like that, and it gives the right class. Next, the visualization of the decision tree. But since our data is already trained, so we can try a cross validation by using the accuracy method. So we have 91.6% accuracy, and also the validation test has an accuracy of 83%. Next, the accuracy score for unseen test data is 86% nearly. Next, we go on to plotting our decision tree, and it comes out like this. So we can see that the values and the class. So if we put a value of the 4 columns, then we'll get the class, right class, and that is our decision tree classifier. Thank you.